I'm wondering if I should do. I wanted to do another separate screen recording, but the last time I tried to do that, it messed up. What? I'm going to be brave and do it again. Really don't want to lose any of the footage. Oh wait, and so hopefully OBS is still recording onto the disk. If not, I should have a backup in Twitch. I really hope this time anything. Okay. What do I do? So I'll be trying to pay attention to the chat just in case you have any questions. Feel free with any message or anything. So I put a link here in the chat, which is the YouTube trailer that I want you to watch, so you have an idea of what actually I'm trying to do. Hoping anyone who joins the stream after this will still be able to see this. So I don't know. The first time I'm using anything is possible. I changed some of the well, my computer fan is like full blast. I hope you can't hear. Okay, I think I'm in the right place now. people in this chat? I don't understand. If there's anyone watching this, can you just leave me a message in the chat so I know you're there? There are lots of it. I'm trying to figure out. I'm looking for a setting that allows me to change the tags just to make them relevant for what I'm trying to do. Don't know where things are. That's what happens when you use something for the first time. Tags. Okay, maybe edit stream info. Okay, I found it. So today I'm not actually, now I'm not doing any 3D printing, so I'm going to put the right, don't tell me this doesn't. Artificial intelligence, do you have? These tags that you get in, the tags that I have available, they are not good enough. We are web development. They need to increase that. You know what? Filming. I don't know what. Okay, you know what? I don't care about the tags because they have very limited tags. The best way for you to find this stream is to understand what the stream is doing. Is look at the title, and I'll put a link to the teaser. I don't know. Okay, so actually I can just create a small clip. Right, so if you're watching this now, first take a look at the YouTube link I've left in the chat, and this YouTube link will give you an idea of what I'm trying to achieve today. Well, this is going to be a long-term series, but if you look at the link, it will help you. Okay, and now I'm going to watch this video clip.
Every year, there are thousands of sightings of big cats across the country. Big cat sightings include jaguars, leopards, panthers, lynx, and even jungle cats. Big cats have been reported to kill cattle and even dogs. Until today, I didn't believe any of these stories as nothing more than a case of misidentification. But everything I thought I knew has changed today. I spotted a wild cat roaming in my garden. I managed to take a picture, but that is not enough to identify it. So, before I go on YouTube saying that I've seen a wild cat roaming in my back garden and make a fool of myself, I need to get extra proof. That is why today, I'm starting a new series on how I built a wildlife camera with a Raspberry Pi, Python, OpenCV, Tensorflow, and who knows what else. This is going to be an awesome camera, enough to capture this wild cat, dead or alive. Alive is possible, just joking, alive. Because the only picture I have doesn't prove that I have nothing more than a cat in my garden. It's not mine, by the way. So, join me in this journey into the unknown. We could potentially discover a new species of cat in the heart of the UK. And who knows what else we find lurking in the dark. What are you waiting for? Let's get started.
A bit dramatic, but you know, I think you get the point. So I have here a Raspberry Pi. It's quite cool, it's transparent. Because it has green, that's cool. I have a green screen behind me, that's why you'll see, you won't see the green. I promise you this is a Raspberry Pi. Right, so I have a box here, which I built, I 3D printed it. Yeah, so I 3D printed this box, and the idea is I slot in the Raspberry Pi inside, I connect the camera, and off you go. So I'm going to do that, kind of, not fully, but I will connect the camera to the Raspberry Pi. So this is going to be interesting because I need to disassemble this, so it's a bit fiddly. Bear with me. Right. Pick the one screw. These are plastic screws, so they are not too difficult to remove. This is a Raspberry Pi 4 with 4 GB of memory. This screws out. One more to go. Okay. So now I've removed the screws, and I can take the top part of this, which will allow me to slot in the camera cable in. This is a CSI connector, and the CSI connector allows me to, it's basically for the camera, this cable here. Yeah, so I normally I need to make sure the blue side is facing down, facing this side. So this tape the blue part needs to face the back of the Raspberry Pi. And I don't know if you can see it, but you can sort it in here. It's too fiddly for me to show you on the camera, but you know, I will have a separate video which I'll publish next week where you can actually see this in detail on how I assemble the camera. Right. So it's connected, and I'm going to, oh, I missed one thing. Oh, what did I miss? The top. Just have to take it off again. I don't want to remove this again. Trust me, this is not interesting. I'm just fiddling with cables. But getting there. If you are wondering what the noise in the background is, it's a train. I live next to a train station, so I get to know the timetables quite well. It's not too bad. At least they don't run at night. Well, after midnight or so. Right. So I have the cable is connected, so I just have to put the screws back on. I don't want to remove the main case. You know, in a normal situation, I would take the actual Raspberry out and put it in the box. But I like this box as well. It's just because of the camera I'm doing this. Okay. So putting the screws back. One. The first screw is always the hardest. I got it. Three more to go. Oops. Right. The last screw is getting. Yeah. I just managed it. Anyway, this camera is a Raspberry camera version 2. In fact, it's not the official Raspberry Pi camera. It's something I bought on AliExpress. And it was a really good deal. I bought it because it came with infrared lights. So the actual this camera itself, you'll notice it has a turns into pink. I mean the actual video itself looks a little bit pink. Because it doesn't have an IR filter. An IR filter is a filter that allows you to remove to basically hide the infrared. The infrared for us, for the human eye, we can't see it, but the camera can. So normally, if you're not trying to do night vision or anything like that, if you're just trying to record during the day, you put an IR filter to remove the infrared. And you can see the infrared light because it looks a bit like pink. So that's what we might see in this camera. Okay, so now it's assembled. I need to switch it on, and I wanted to do it somewhere around here. I'm going to get my just getting the power supply. So this is a power supply for the Raspberry Pi, the USB C type. Connect it like this. The power. Then I'll put this in connected somewhere. It would be nice to actually have the view of outside. And face the camera outside, so you can, when we get a little bit of image, you will be able to see. You'll be able to see the camera, like the outside view. Just managed to switch on. All right. Oh man. Yeah, that's a bit of exercise for me. So I've connected the camera. I've switched on the power, so I should be able to access the Raspberry Pi. Let's see how it goes. Okay. Right, so next step, I'm going to connect to the Raspberry Pi. Just opening remote desktop. So I actually downloaded Microsoft Remote Desktop, so I don't need to have a monitor connected to the Raspberry Pi. There's some advantages and disadvantages, but for me it's convenient. So it's just My host name is Raspberry Pi. Just have to log in. We want to take over the whole screen. Only. Okay, so this is a Raspberry Pi. I think I wanted that. Okay, so this is. Okay, right. So I've already gone through a setup of making sure I enable the camera and I have all the packages upgraded. If you have any questions on how to, if you have any questions on how you set up a stream, sorry, how you set up a Raspberry Pi camera, I'm going to be releasing a video next week which shows you the main steps. Okay. So the first thing I need to do, I'm going to take a picture, see what the camera sees. I'm expecting the lens to be out of focus because I've kind of disassembled the camera. I took the lens off and I'm going to take, so I'm going to create a stream out of the camera and connect to it using VLC. So I've created an RTSP stream out of the camera, which allows me to basically see what the camera is seeing in real time. And it will be easier for me to actually focus the lens if I see what the camera sees. Hopefully. So what's happened to the VLC is not happening. It's not opening. Anyway, even if I have an issue, I don't need to use VLC here anyway. Maybe it's too much because it's actually streaming. Oh. Let's see what happens here. Can open it through the terminal. Okay. Open network stream. It should be on a local host. When I started the stream, I used the option to, I made it run on 8554. By the way, whatever I'm doing here, I go in detail in another episode, which I'm also going to release next week. So I'm just not, the goal of this stream is not to go and repeat everything I've done before and explain everything in detail. It's just to go, you know, it's a series anyway. So, okay. So let's see if I can connect now. All right. So this is the stream. It's very fuzzy. going to try and focus a bit. Connection. Okay, so I just need to use the okay. You see the image itself looks a bit pink. It's because of the lack of IR filter. Don't know if I'm in the right direction. There's a bit of a lag, so it's a bit hard to focus. Oh my goodness. Okay, so I'm going to focus in one direction. I'm going to try and wait. Better. Stop the stream. This is not the best quality camera you can get, but the point is, it's definitely not going to be the camera I'm going to try and capture wildlife with. Starting point. Getting point. I'm going in the right direction in terms of focus. Okay, that's right. Okay, I think for now it's good enough. So let's see the outside world, whether I need to probably reduce the ISO because there's a lot of light outside. It looks almost like, I can't really tell anything, can you? So overexposed. outside. Okay, you can't really tell. It looks like only clouds, but there's actually more than that. So let's see if I can control exposure. Raspberry has some options to change the ISO. The ISO is something that allows you to control how bright the image is. Exposure mode, ISO. At the moment is 6. Let's just play with this. See what we get. Minus ISO. Let's see, 500. I can't even tell. Because this outside. Let's cover. Okay, outside is probably not a good idea. Taking into account that this, I don't have an IR field right now, and it's not very good. Point it towards the room, so you can see it's pointing here. The image is very, very bad, but this is only our starting point. I could do it better. Let's try and increase the frame rate. You should get 20 frames per second. Try again, VLC. Should be a bit smoother. Yeah. The worst image. Yeah. I wish I could. Oh, much better now, right? All right. So maybe I'll try and smile to the camera. Okay. Right. Okay, so what else? So I wonder if an object detector would even work with this quality of image. Might. I have a much better camera. But for now, we'll do with this. What I want to do for our basis of development, I want to have, I like to use Docker, and with Docker it's much easier to basically because with Docker you can create a container with all the dependencies, all the libraries that you need, and you're good to go. So we need OpenCV, we need -3, we need TensorFlow. We're going to try the TensorFlow version 2, and I'm going to try and find the TensorFlow which is already compiled, ready to go. Need to see. Okay. So let's find TensorFlow Raspberry Pi. I think TensorFlow used to have some images for Raspberry Pi for the ARM processor. But I don't want to build it from source, it will take a couple of hours for sure. I did this in the past. So there is already a TensorFlow image with Docker. I'm following the TensorFlow guide here. So we kind of left for a second the camera on. It's running, no problem. It's just that I need to start thinking about the different components for this project. I'm just setting up the basis for later on, make things easy for me. So I need a Docker container with TensorFlow, with Python, and an OpenCV. And we need probably an OpenCV with lots of options in terms of drivers it supports and so on. But let's follow this guide. Install Docker. It's telling me to download TensorFlow. Checking out the branch, I guess it will be a release branch, a stable one. Then build from source, I don't like that. I remember having some Docker images already ready to go. Okay, so let's have a look at the Docker images that are already ready to go, so we don't have to waste time compiling TensorFlow in a Raspberry Pi, which can take an hour or two. So I need to look at the images that I have available here. So most of these images are going to be for AMD 64. That would be compatible with x86, but if I want to actually try on the Raspberry Pi, it should have ARM, which is type of processor. So there's no ARM option here. So if there is no ARM, if TensorFlow doesn't have an image for ARM architecture, that means I have no option. I have two options. Look for someone who has done this in the past. I've done it for another version of TensorFlow, or build another Docker image for TensorFlow. Don't like. Okay, so this seems like does it work on a Raspberry Pi? I'm not sure. There's a TensorFlow Lite which is specific to the Raspberry Pi. I've run Raspberry Pi, the full version, before. Maybe I have no choice. Someone has done it. Let's see what they say.
Hi, today I'm going to show you how to install Tensorflow 2 on a Raspberry Pi. I'm using a Raspberry Pi 4, but this will work for a Raspberry Pi 2 all the way to. I'm going to SSH first into my Raspberry Pi. If you do not want to SSH into yours and you're using a display, that's just fine. Get to the same point as I am, just open up a terminal. Okay, first things first. Create a virtual environment. I like using virtual environments for package management in Python just because it keeps packages that shouldn't be together away from each other. To that, I'm going to first make my project directory. My desktop, let's call it directory TensorFlow Pi. Change directory into that directory, and now you might not have virtual env installed. So we're going to install that. I already have it installed.
So you picked a repository which seems to have already a pre-compiled version of Raspberry Pi. Oops. But this is not official. This is a code. Anyway, going back to the video.
But for those of you who do not have installed, Python 3-m pip install virtual m. All right. Next, we want to activate our virtual m and create it. So do that virtual m, and then m. I can call this anything, my m, whatever. I'm going to call it m. Finished. Now we have to activate the m that we created. To do that, we'll call source name.
Okay. So I'm going to go to GitHub. So I'm going to create a new repository. I'm going to call it Raspberry Pi Docker Tensorflow OpenCV. Okay, this should be good enough. Oh, they're with me now. It seems like I have two threads open. Oh no, the one it was VLC, it doesn't matter. I'm going to do something else for now. So I know I'm going to get an error. Oh no, worked. Okay, so I was able to. So I'm going to create a new Docker file. Done this before, but just find my projects in the past, see what I've done. Oh yeah, I have a good example. I did a smart lamp that can tell you the weather in the morning, and I created a Dockerfile for that, and it was quite handy because this Dockerfile starts with this. So it already has Python, and it has the libraries I need. RC. You have to be careful with the libraries that you choose, the Docker images that you choose. They need to be compatible with ARM if you're trying to run it on a Raspberry Pi. So anyway, it's I picked. No, I'm just going to keep the same. I want to invent too much now. What I'll have to do is, I think I need to integrate my IDE. Docker. So I'm going to also copy the Docker Compose as a starting point. I'm trying to do it lines, but I'm doing that. Okay, so I'm just going to change the service name. What do we call it? I'm going to call it camera for now. Do I have a better name? Better now? Okay, so now if I try to do Docker Compose By the way, I should have another Docker running. My sudo docker. I need to add my user to the Docker group, so I don't have to do sudo all the time. But I already have a Docker container running. This is my Docker container I set up to basically get the weather information and then change the light based on the weather. It's quite a cool project. I also have a YouTube video that you can check out on my channel on YouTube. Anyway, so I'm going to try and just get this Docker container to start without doing anything for now. I think I need to sudo again. Right. Okay, so I need to build first. Okay, I'm going to make sure my user has permissions for Docker, so bear with me. So I'm going to go and find out how to add it. There's a setup for that. How to add user to Docker group. So what I need to do, I've already installed Docker. I'm just making sure. Okay, I want this. So I don't have to be bothered again to call sudo whenever I do something with docker-compose. So docker-compose. Oops. I need to exit and start again. So I can test now. Maybe I missed something else. Oh. Did I do wrong? So docker ps -a permission denied. It's missing. I've done this before. I know, like GP. This is different. What's the difference? But I know I need to start a new terminal, but Seems like I'm still not part of the group. Why? Oops. Yeah. Okay, I might have to figure this out later. It's not important. It's just a small annoyance. The Docker, so if I do sudo docker ps-a, I already have the container running for some reason. But I remember that. Failing with an error. See what's going on. Okay. So why is it? So in the camera. Again with the sudo. I think it doesn't do anything, that's why. That's why I kind of keep restarting. It doesn't do anything. So I didn't really put any instructions to or anything. So I can do one thing, which is I think command cmd I'm trying to find the keys, by the way. I saw it. Okay, so okay, found it. It was actually in the right place. But this keyword is configured. One second. Right. Okay. So I'm going to do a tail. What? Don't you know, I'm just like remembering the syntax. I might have it wrong. Okay. Docker compose. Couldn't connect. Okay, so let's see if now when I start Docker again, it will stay up. Clear the screen. Anyway. So clear. So I'm starting the container again, the camera container, and if I'm lucky, it's still up and running. Yeah. What? Yeah, it's up. Oh, it's starting. What's there? No error. Oh, I forgot to add the -f. My fault. -f means to actually wait. Basically, -f is keep checking the file. Okay. Build. Okay. So, right. Now it should work. Shouldn't just exit. I just want to have the container up and running because it can be useful to check what's inside, what's not. Okay, so as you can see, it's up now. I can actually go inside the camera, inside the container, and check what's inside with the docker exec sudo. I'm not going to get rid of this. Okay. Okay, so I'm already inside the container. It has Python 3 already set up. And what I want to do is to try and follow those instructions that is in the YouTube to basically just add everything that's needed. And I'm going to copy and paste this stuff here. I mean, a virtual environment in Python is almost like a separate zone that you can do things and without worrying about any other libraries that are installed in your environment, in your operating system. But because I'm using a Docker container, that's kind of the same thing, so I don't need to create a virtual environment. I'm not going to do this. I'm just going to follow these steps here, Dave. It would be something. It's done. It's installing carers. It's installing a bunch of stuff, which I'm not 100% sure it's actually needed. What I really want is TensorFlow. Well, let's go with version 2.3.0. Copy link address. Wait, the asset. I need to use the right architecture. I think ARM7L, the correct one. Yeah. I don't have TensorFlow as far as I know. I don't need to. I need to uninstall what I don't have. Oops. Undo. -3. The mistake. Damn it, I think I lost the URL. Okay. Need to copy. Yeah. And then let's see if this works. I'm just going to do a build of the Dockerfile again. Oh, need sudos. I don't even know if apt-get is something I can use within the container. Let's find out. Oh, more sudos. No sudo. So actually each command in Docker needs to be preceded. If you want to run something in the shell, you have to use run. And I forgot to do that. Run. Don't know why it's going. Well, I shouldn't have to do. pip3 should install what I need. So let's try that on its own. I'm going to comment out all the other lines for now. It's okay. I don't know how to comment out in keyboard. I'm going to do a build. Client 5. I don't know if those libraries actually needed. Okay. But there's no apt get. No, that's another issue. I need to basically sometimes if you don't update your apt-get command, it will have out-of-date repository references. So you need to do this. I think that's the error. So I update first, then I can download anything I want. Okay, it's installing hopefully TensorFlow, and it's installing Keras. I don't think it's needed, but I copied and pasted everything for now. I might want to stream it, basically to trim it down just to the essential. I don't even know what these libraries are for. So there are dependencies, okay. So I just I'm just waiting for this to complete. Okay, so failed. You know, when things fail, things are going according to plan. I'm not joking. No big deal. I'm getting an error. I don't know what the error is just yet. This step here failed. So H5PY. I don't even know what that is. Honestly, I need to check it out. This is what I've done, right? Except we're trying to force the version to be 9. Wow. So I'm getting an error, which is a mile long. And I don't know what. To be honest, I don't even know if this library is really needed. I would hope it not. Then I don't have to spend time figuring out what it does. See what this is. H5P. nice to be having issues with. Am I going? Am I going the wrong way? Am I doing the hard way? Trying to go. This is another guide for installing Tensorflow 2 on a Pi, right? It does have official packages, so why am I doing here? I'm just trying to build something that I don't need to build. I looked earlier at the Docker containers that Tensorflow releases. I couldn't find any Docker container already set up for the Raspberry Pi. But I'm a bit confused, honestly. But I could just do this and see what happens. And skip that horrible error. Camera bash. Right. So I'm just going to try and install it here directly and see what happens. I wanted to install version 2. If it installs version 2, I'm very happy. There's no requirements that satisfies. Okay. Pip the install upgrade minus pip. So let's hope that upgrading pip actually helps. I don't see how it can. But it does say in the documentation you should have the latest version of pip. But it doesn't have. Can't find the package. Why? I'm missing something. Okay. I mean, it's the same. Control. I'm downloading TensorFlow. Let's see if I'm lucky with the installation, whether it actually requires any of the prerequisites. The documentation is not very clear. Okay, so what does that mean? It's not supported wheel. Oh, but okay. Out of curiosity. Okay, so already with Python. It's already there. It's not looking good. I think I'm going to stick to oh. So I'm a bit stuck with Docker and TensorFlow, but I know from the start this is the hardest step. It's old. I want TensorFlow 2. So the Raspberry Pi 4 is giving me a headache. TensorFlow 2, Raspberry Pi 4. Same instructions. It seems like someone managed to create an image already. So a bit out of date, but I can find the Dockerfile. Or maybe I try this one. And so I can just replace this URL with the latest version of TensorFlow. TensorFlow. I'm just going to copy this URL. Hopefully it will work. Okay, let's try. This might take a while. If it goes well, I'll fail quite quickly. I'm going to have a small break while this is running. Yeah. Okay, I'll be back in a minute or two. Still running. I'm going to get a coffee. I'll invite you to do the same. All right, I'm back. Made a coffee. Nice, right? From my Christmas. Still running. It's a good thing. No errors. You know what? Why don't I just run my trailer while you're watching? If you haven't seen it, you might as well figure out why I'm doing this. Still learning a lot about Twitch. Is there anyone on the channel? Please say hello if you're there. In case I have no one watching. It's a bit depressing. But if there's no one watching, may as well not play the teaser again. Kind of at the beginning of the stream. All right. It's actually quite nice Saturday afternoon, stay at home, just do some coding, have a nice warm coffee. Yeah, what's better than that? I see that someone actually joined the stream. Hello there. Thank you for joining. Yeah, so I'm here building a wildlife camera with a Raspberry Pi, just for fun, really. If you want, I'm going to put here the link in the chat. They can watch the teaser I created on my on a YouTube channel, Fundamental YouTube channel. Should be fun. Let me just share the link. And hopefully you enjoy it. And then if you think this is something you want to try, then, you know, I'll be doing a few streams. It's going to be a long-term project using not just the Raspberry Pi, the camera. I'm going to use a camera with night vision capabilities. I'm going to do Python, of course, the programming channel. I'm going to be using doing some AI using TensorFlow, object detection. It's going to be really fun, really. But you know, it's a long term. In all between the fun, then you have to basically be patient, because sometimes you just have to set up Docker, or you have to install TensorFlow in a Raspberry Pi, and sometimes you get stuck somewhere, like I did this afternoon. But I think I've managed to get it working. But anyway, That's the fun. You know, when you get the results, it really means something. So yesterday when I was also doing some programming, I had an eagle show up in my window. It's not really an eagle, it's called what do we call it? It's called sparrowhawk. Yeah? If I had my wildlife camera already ready to go, I would be able to take a video clip out of it. But it's interesting that it happened. I'm going to show you the picture. Actually, quite. I never had that type of bird show up at my window in my roof. So do you see this? This is a sparrowhawk. I live in London, and apparently they are not uncommon in the UK, but trust me, the thing I see the most around here is a pigeon. They normally come quite often here, but this is a special bird. So if I had the wildlife camera ready, I would have been able to capture it. Well, I took a picture of it, I was lucky, but you know, a video clip is much better. And who knows? I've only noticed the bird here once, but maybe it comes quite often. Just checking me out. Right? Okay. So seems like okay, still installing. So I might as well keep chatting myself with whoever's on the other side. If you are around, you know, I would be curious to hear about the motivation you have. If you are trying to learn programming, or if you want to maybe learn Python so you can create games. In the morning, I was doing a small, my first stream actually. I was doing some Python with Blender, and I had someone who actually wanted to learn Blender. All possible, really. Just have to put hours. I'm just talking because this keeps. I'm still waiting for my compilation to finish. I'm still installing Tensorflow. Taking a while. Maybe I can switch on the camera in the meantime. Again, Raspberry bid. Let's see. Might not be a good idea because I'll just do it for a second, but I don't want to slow down the process of installing TensorFlow even more. Well, just to give you a start the VLC. So I opened just now a live stream from my camera, my Raspberry Pi camera, which is open. I'm going to just open it so you can see it. The RTSP stream has a bit of a lag, but not too much. Oh, see? I'll say hi. Look. Yeah. It's a bit out of focus because I had to remove the lens from the camera, and I don't think I've managed to focus it too well yet. At some point I will. Okay, I'm going to close this down again. Okay. So probably can hear the sound. I live next to a train station. Not too much the sound. Waiting. So the next thing, I guess we can check. The next step would be to run OpenCV. I don't know if you heard about OpenCV or not, but OpenCV is a fantastic framework for manipulating video, and is actually used in a lot of. If you ever study computer vision, you'll come across OpenCV for sure. It's the thing that you must learn, and we're going to use this in the project. So that another fun thing is going to be to try and install OpenCV in a Raspberry Pi. I think previously I used OpenCV binary that's already created by someone else, but last time I tried it didn't work. It's OpenCV4 fine as well. I'm going to do that in a separate live stream. So right now I'm just setting up all the environment, the development setup. Right now I'm still working within the terminal. I'm going to, because I prefer to develop in my own local computer, I'm going to set up a synchronization of source code between my computer and Raspberry Pi. There's quite a few steps to go through before I actually start doing the thing that's most fun, which is actually writing the source code. Hello. So I see that someone joined our stream. Welcome to the channel. Because I've let me just paste the link for you. If you want to know what I'm up to very quickly, you'll be able to just play a 2 minutes video clip. So it gives you a context. I'm going to figure out at some point how to make it part of the actual channel description or whatever, so that I don't have to keep giving the link to everyone. But if you watch that 2 minutes video, you'll have an idea of what I'm up to. I think it's a very fun project. Anyway, right now, the current state of affairs, I'm installing TensorFlow in a Raspberry Pi, and actually it takes a bit of time. So I'm just waiting for this to complete. If you have any questions or anything you want to ask, this is the best time. For instance, I'm actually curious why you what is the things that you're interested in? What is that you want to learn? Or you're just curious about? I don't know, maybe you're curious about Python or Raspberry Pi or TensorFlow. Yeah, just let me know. To say hi. Yeah. Right. Wish I might need some music at some point. Might stay using, and I wonder if I can just pick a music from some list that I have. Music. No. Still running. Still installing. Well, in the meantime, while this is running, I'm going to give you a good suggestion, I hope. If you are interested in data science, AI, there's a Kaggle.com website. In Kaggle.com, you can actually complete a few courses. I've taken a few. You can learn Python, get a certificate from Kaggle, which is quite nice. If you don't know, Kaggle is actually owned by Google. So if you ever aspire to be a data scientist or work with machine learning, very highly paid careers, to be honest, this is a place to come to learn the basics. So there's a course here called Intro to Deep Learning, which at some point I want to actually do this. So I'm going to do this course. I haven't really started yet, but you can see there is like a lot of theory that you can learn and some exercises, so you get the basics of deep learning, and that gives you another advantage when you try to do anything with machine learning. Okay, I'll do that later. I'm not going to do it now, but you know it's here. You know what? Why don't I entertain you with my YouTube channel while you're waiting? First, we can do the teaser.
Of the country. Big cat. Every year, there are thousands of sightings of big cats across the country. Big cat sightings include jaguars, leopards, panthers, lynx, and even jungle cats. Big cats have been reported to kill cattle and even dogs. Until today, I didn't believe any of these stories. Nothing more than a case of misidentification. But everything I thought I knew has changed today. I spotted a wild cat roaming in my garden. I managed to take a picture, but that is not enough to identify it. So, before I go on YouTube saying that I've seen a wild cat roaming in my back garden and make a fool of myself, I need to get extra proof. That is why today I'm starting a new series on how I built a wildlife camera with a Raspberry Pi, Python, OpenCV, Tensorflow, and who knows what else. This is going to be an awesome camera, enough to capture this wild cat, dead or alive. Alive is possible. Just joking. Alive. Because the only picture I had doesn't prove that I have nothing more than a cat in my garden. Not mine, by the way. So, join me in this journey without knowing. We could potentially discover a new species of cat in the heart of the UK. And who knows what else we find lurking in the dark. What are you waiting for? Let's get started.
Now, if you know what's at stake here, you can actually find some courses I've created.
Hello, welcome back to the Code Mental channel.
So if you want to learn Python, I have a small course I created for Python for beginners. I've also, if you are into 3D modeling and Python as well, I also created a small like series where I show you how you can create a 3D model using Python and STL, no, Python and NumPy. Anyway, and then at some point I'm going to finish the series, right? And with still running. Kill time. Okay, still installing. I need to have a break, but no, I'll come back. But I'll let it run. Hello. Yeah, I'm currently just waiting for an installation of TensorFlow to finish. So there's not much more I can do. I invite you to watch the teaser that I created for this series that I'm creating on YouTube. Yeah, if you enjoy it, then you can follow me. Nah, sure. Find that. So this is the. You can go to the Code Mental channel, take a look at the teaser. If you like it, then yeah, you should join me. I'm not finished yet. I'm just having a small break. In here for like 3 hours already. Not yet finished, but because I have to wait for the Raspberry Pi. I'll be curious to know if you have any motivations. You know, maybe you're learning Python, or you want to learn. I don't know. You want to Raspberry Pi as well, and you want to fun with it. You know what kind of makes you curious about this stream. And if you have any questions, really, opportunity to ask. So the struggle I'm going through now is I have to set up TensorFlow version 2 on a Raspberry Pi, and as you can tell, it takes a while. Okay. I have a Raspberry Pi camera, which I already set up. If you want to see it here. It's not very good quality, but I'm not worried about the quality of the image just yet, because I have so many other things to do first. Like I'm installing TensorFlow, I need to set up OpenCV, I need to have a reasonable development environment. That all takes time. For that. Do 5. All right. Seems like it's moving. So it's gone to now it's setting up the h5py package. Hope that works. Hello? I'm going to have a little break. Hello, I'm back now. So I had a small break. Still waiting for Tensorflow to install. Takes a while. I need to fill in the gaps, I guess. Okay, so installed one more package. Get in there. 9 out of 14 now. So it's installing some other packages. Just to give you an idea, I'm actually creating a Docker container that I can use later on for development, because I'll be using TensorFlow, OpenCV, you know, those Python, of course. So I need to have a container which has everything I need. That's why I'm getting. And by the way, you can see here this very lousy image. It's the camera, the worst camera I have. Later on, I'm going to, because this is going to be a wildlife camera, so I need to be serious about the camera. I'm going to get, I have another camera which is actually much, let me just, I'll get it, yeah? I'm not going anywhere. So, back. Okay. So if you are curious what I'm up to. Okay. Anyway, I have better cameras here. They actually have an Ethernet cable, but you know, with an Ethernet cable, I can actually connect it to the Raspberry Pi, and I'm not limited by. I can have any camera I want with good capabilities, with good image processing. And the idea of having the Raspberry Pi is I can apply some AI, object detection, outside of the camera, but I can detect whatever I want. In this case, I want to detect cats. I could also detect birds if I want to, or whatever is the thing I want. So this is, eventually I will use a camera like this one, or there's another option. Raspberry Pi has launched a new camera called the Raspberry Pi Camera HQ. I find it a little bit expensive. So HQ. Look. Like, just this is just for the board. Costs you £50. And then if you actually want the lens, it's another £50. So it costs you £100. But it's a much better camera than the one I'm using right now. But I think these cameras I have are even better. Well, especially this one. It's a small camera, but it has a low light sensor, so you can actually record in true color at night without using RFID. Sorry, without using RF infrared. Not IRF, sorry, infrared. It's very, very cool camera. So I've already recorded a video with showing how it works. I wish you soon. With this camera, you'll be nothing. Alright, so it's now installing TensorFlow. I'm almost done. Getting dark here, or is it light? Okay. What I want to do is actually publish this image into Docker so that I don't have to always build it again. As you can tell, it takes like an hour or something to just build this. So if I want to be a good Samaritan for anyone else who is trying to do the same as me, I would publish that into the Docker Hub. I'm going to do so. It's almost there. Should I even try to set up OpenCV today, or should I just call it a day? The last thing I want to do is having to do this compilation again. Still going. Right now it's not a good idea to try and run anything else. In the meantime, I'll try and do this Kaggle course. See if I don't want to be doing nothing here. Okay, courses. Intro to deep learning. Right. Oh, just when I was about to do something else, this says finished. Come on. I was already into the idea of studying deep learning, and this finished. Fantastic. Okay. Let me just have a look at this Dockerfile. I'm going to publish this Dockerfile so that I don't have to do this ever again. I can just download the Dockerfile and I'm done with it. So how do I do that? I need to go into my Docker account, which I'm not going to share in public. So sorry if I'm not really showing you what I'm doing right now. I might even have to hide. The way it works, you get a free account in hub.docker.com. You can create a repository. And I already created once. Tensorflow. Let's see. Tensorflow. I have created in the past a few packages for Tensorflow. Anyone? Tensorflow. TensorFlow 2, Raspberry Pi 4. What do you think about this name? Looks okay? I think I need to add a tag or something so that okay. I'm going to create. What I could do, actually, make this first. I'm not sure whether well, anyway, what I'm trying to do is create a new repository in Docker Hub. Do I need to do a Docker login. I have to hide my made a mistake. Okay, so I've managed to log in. So I can show you my. Right, so I can do a docker push. Basically the command is this one. Need to use sudo for now. And I'm going to try and use the actual version number here to identify which version number I'm using. Okay. It will be easy to identify it. Control. Thank you for it now. Okay, so I'm pushing the image I have created. Of course, I always need to put sudo for now. Oh, because I'm renaming the image. I need to figure out how to. I need to figure out how to actually rename the image. Because I give a name, docker name. Okay. Hmm. Shouldn't affect anything I've already built. see if this works. Okay, seems like it worked. So it's now uploading the image to the repository. Oh, well, like you can see my head. Oh, you can only see my head. That is hidden. Right, I'm almost finished here. Almost 4 hours stream. Sorry, I just looked on my left. Access to the resource is denied. I thought I logged in. I clearly logged in. I have to log in again, don't tell me. So I've managed to log in again. I'm hoping now. Oops. So it's doing it. Might take a while. In the meantime, I have recorded some video clips before, which were to show the different types of camera. I think let's try this one here. This is using the same camera I showed you earlier. And this is with a higher resolution, still the same. I took also some pictures. This is with light switched on. This is like artificial light, that's why you don't see the pink in the camera, because the pink comes from the sunshine. Interesting to know, right? Then you have low light here. Not this actual light camera, but it doesn't seem. Okay, I thought you had it. No. Anyway, it's still. I'm going to be releasing an episode soon on YouTube, on my YouTube channel. You can find you can find it in my. I have a link to the channel. It will have a comparison of the different cameras, and it has. You'll find it useful. Don't know how long this will take. Maybe I will just try and speed it up by doing something else. Yeah, so let's just don't lose track of. So let's see if we have time to just do a bit of learning about deep learning in the Kaggle website. Welcome to deep learning, like that. Welcome to the Kaggle's introduction to deep learning. You're about to learn all you need to get started building your own deep neural networks using Keras and Tensorflow. You will learn how to create a fully connected neural network architecture, apply neural nets to two classical ML problems, regression and classification, train neural nets with stochastic gradient descent, improve performance with dropout, batch normalization, and other techniques. The tutorials will introduce you to these topics with fully worked examples, and then in the exercises you'll explore these topics in more depth and apply them to real-world data sets. Let's get started. Like that. So by the time I will get started, this will finish, and I'm going to do a separate stream for this, so don't worry about it. Just killing time. What is deep learning? Some of the most impressive advances in artificial intelligence in recent years have been in the field of deep learning, natural language translation, image recognition, and game playing. Are all tasks where deep learning models have neared or even exceeded human-level performance. So what is deep learning? Deep learning is an approach to machine learning characterized by deep stacks of computations. The depth of computation is what has enabled deep learning models to disentangle the kinds of complex and hierarchical problems found in the most challenging real-world datasets. Through their power and scalability, neural networks have become the defining model of deep learning. Neural networks are composed of neurons, where each neuron individually performs only a simple computation. The power of a neural network comes instead from the complexity of the connections these neurons can form. It's actually quite a lot of fun. The linear unit. So let's begin with the fundamental component of a neural network, the individual neuron. As a diagram, a neuron or unit with one input looks like X and 1, the linear unit. Okay, so this is where I'm starting to, I have to figure out what this means. X and 1. So X is, I guess, is a variable number. 1 is a constant. What does W and B means? I think what W is the weight, and B is what? It's a constant, I guess, that you add. B equal to 1, I guess. The input is X. The connection to the neuron has a weight which is W. Wherever a value flows through a connection, you multiply the value by the connection's weight. For the input X, what reaches the neuron is W times X, which is the weight. A neural network learns by modifying its weights. Actually, this is a good example. So a neural network will vary, for example, the weight from 0. Weight equal to 0 means it will ignore X completely. And then on the other extreme, it will, W equal to 1, it will be taking the whole value of X. But then it will actually vary between 0 and 1. That's the weight. So the weight varies between 0 and 1, if I understand well, or even more. Actually, it can be 2 times X, 3 times X, I don't know, where does this stop? The B is a special kind of weight we call the bias. The bias doesn't have any input data associated with it. Instead, we put a 1 in the diagram so that the value that reaches the neuron is just B. Since 1 times B equal to B, the bias enables the neuron to modify the output independently of its outputs. Independently of its inputs. You put the 1 in the diagram so that right. Okay, the bias enables the neuron to modify the output independently of its inputs. The Y is the value the neuron automatically outputs. To get the output, the neuron sums up all the values it receives through its connections. The neuron's activation is Y equal to W times X plus B. Or as a formula, Y equal W times X plus B. Okay, this is I think it's familiar to me. I've seen it somewhere. Does the formula y equal to wx plus b looks familiar? Okay, before I even see what it says there, it looks like the equation for velocity, right? Slope-intercept equation. Like when I was studying physics, I remember seeing something very similar to this. But you know, this was ages ago. Okay, let's see. Too abstract for me. I just want pictures right now. I think oh, okay. It's a mathematical function that basically goes. Okay, I remember now. So if you don't have the b, actually you have like a straight line that goes through the origin, which is 0, right? Then plus b, you basically move the line up or down. So that's what it is. I'm pretty sure this is also the equation that you get in physics for calculating a position. But I don't remember what I'm talking about. But you know, this is like familiar for sure. Okay. Still going, still taking time. So go through this. Right. Us. Okay. The linear unit as a module. A model. Though, did you hear that? My daughter is making some noise. Let me just close the door. I don't have to do that. So, right, so continuing. The linear unit as a model. Though individual neurons will usually only function as part of a larger network, it is often useful to start with a single neuron model as a baseline. Single neuron models are linear models. Okay, so we start easy. Let's think about how this might work on a dataset like 80 cereals. What's that? There's a dataset. Nice. Nutrition data on 80 cereal products. Sounds good. Might be fun. We have time to do it. I don't think we do, because this will take less time. Okay. But this looks like a very fun course to do. I would recommend you do that as well. Training a model with sugars, grams of sugars per serving as input, and calories per serving as output. We might find the bias is B equal to 90 and the weight is W equal to 2.5. We could estimate the calorie content of a cereal with 5 grams of sugar per serving like this. Okay, let me just absorb. I've just read a bunch of things that I didn't really understand, so I'm going to try and focus with the light. So input is grams of sugar per serving, and calories is the output. So we're trying to find the relationship between calories and the amount of sugar, right? And it tells me that we might find the biases is equal to 90 and the weight is equal to 2.5. We could estimate the calorie content of a cereal with 5 grams of sugar per serving like this. 2.5. Okay, so this is showing me the diagram. So sugar is 2.5 grams, and then the weight, the B equal to 90. That's the calories. So input sugar is equal to 5. Oh, I see. This, so 5 times 2.5 plus 90, right? And that gives you 102.5. Okay, seems like my Docker image is pushed. So although I do like this course, I think I'm going. Oh, see, I see that someone joined me. Just to give you an idea what I was trying to do, I created a Docker image with Tensorflow, and I pushed it to the Docker Hub. I'm building a Docker image for Raspberry Pi 4, and it basically, unfortunately, I couldn't find any Docker container that already had Raspberry Pi TensorFlow for Raspberry Pi 4, TensorFlow version 2. In this case, version 2.3. So I built the image by copying from somewhere on the internet, someone who did something similar, and I just built the image and I pushed it to the Docker repository, and it was taking a really long time. So I was actually going through this Kaggle course, which is very nice. If you want to learn about deep learning, I highly recommend. This is a course which gives you all the basics. And I was already almost at the end before the exercises, so I might as well just continue like for 10 more minutes. And if I feel like it, I still can do the exercises. No. So we were just checking here this example. 2.5 times 5 plus 90 equal to 102.5. So we are studying a neural network with one neuron. It's a very simple one. And this is actually giving us the basics to understand when you actually get lots of neurons. The machine learning process is all about changing weights, making lots of small changes in variables, and seeing what you get. So the computer can do that very quickly, right? So it can do lots of calculations, and then it has some reference data that it uses to try and train the model. And with the reference data, you're able to see, you kind of can control more or less whether your model is kind of giving the right responses. But yeah, just to give you an overview of neural networks. But at the end, like once you train your model, normally you use another set of data, which you didn't use to train the model in the first place. It has to be a separate reference of data. Then you basically, when you finish building your model, you can compare, you basically can run the model you've created against the test data, and then you can score your model based on that. So the idea of that is that if you create different models, you need a way to understand which one performs better. So that's why you have to have a set of test data. And it's not easy. Sometimes I've worked with a friend of mine on on a neural network to basically detect, in this case we were trying to detect knives in a video, and even though we had training data and test data, we still had some issues when actually using on the field. Anyway, I'm going to continue and up to the end of this, and then I'll finish the stream. Multiple inputs. The 80 serials dataset has many more features than just sugars. What if we wanted to expand our model to include things like fiber or protein content? That's easy enough. We can just add more input connections to the neuron, one for each additional feature. To find the output, we would multiply each input to its connection weight and then add them all together. So x0, then you have weight 0, then x1 weight 1, x2 weight 2, x, and this is our bias. In this case it's b. The formula for the neuron would be y equal to w0x0 plus w1x1 plus w2x2 plus b. A linear unit with 2 inputs will fit a plane, and a unit with more inputs than that will fit a hyperplane. Oh, I see. What is a hyperplane? I think it's probably you have x and y axis, and then I don't know what a hyperplane. This is where a bit of knowledge I didn't know. Sorry, I'm kind of from what I understand is okay, I don't understand this yet, honestly. It says that a hyperplane is a plane that has one less dimension than I think it's to do with I see you have 3 dimensions, and your hyperplane is something that only fits into 2 dimensions out of the 3. But you know, it's the first time I hear it. I'm going to take it easy. I don't want to learn too much. Hyperplane. Linear units in Keras. Okay. The easiest way to create a model in Keras is through keras.sequential, which creates a neural network as a stack of layers. We can create models like those above using a dense layer, which we'll learn more about in the next lesson. We could define a linear model accepting 3 input features: sugars, fiber, and protein, and producing a single output, calories, like so. So it's importing the keras from TensorFlow, importing layers from TensorFlow.keras, and then it's creating a network with 1 linear input unit. The layers.dense unit equal to 1, input shape equal to 3. I'm going to pretend I understand what I'm just. No, joking. So 1 linear unit. So how many units we want? Our output is only 1 calories. So we use units equal to 1. With the second argument, input underscore shape, we tell Keras the dimensions of the inputs. So in this case, the number of inputs that we have is 3. So we have sugars, fiber, and protein. And the model is now ready to be fit to the training data. Why is input shape a Python list? Why is it not a tuple or maybe a NumPy array or whatever? I'm just adding that. The data we'll use in this course will be tabular data like in Pandas data frame. We'll use one input for each feature in the data set. And the features are arranged by column. So we always have input underscore shape equal to number of columns. The reason Keras uses a list here is to permit use of more complex data sets. Image data, for instance, might need 3 dimensions. So it's like variable in terms of number of arguments you can give. Do I really have time for one more exercise? I don't know how long this will take. But I almost can't help myself. Let's see. I'll start it. If I decide I need to have dinner or something, I'll have to stop. Okay, so I've done the theory, and now I'm going to do the exercise. In this tutorial, we learn about the building blocks of neural networks, linear units. We saw that a model of just one linear unit will fit a linear function to a data set, equivalent to linear regression. In this exercise, you'll build a linear model and get some practice working with models in Keras. Before you get started, run the code cell below to set everything up. So this is just a Python notebook, and it runs on its own server. Google owns it. It doesn't really matter for us. I'm just running it, so it's set up everything. I'm going to be using pandas. The red wine quality dataset consists of physiochemical measurements from about 1600 Portuguese red wines. I'm Portuguese, so I'm proud of that. We have 1600 red wines. We're just like 10 million people. Not even that. And we have this many wines. Also included is a quality rating for each wine from blind taste tests. First, run the next cell to display the first rows of this data set. So we're going to use pandas for this. So I can see the code is importing pandas. It's also importing a CSV file, which already should be there. And we're going to have a look at the starting part of the data set. So this is a good thing to do. No. What happened there? I thought I was running everything. Okay. So I want to do something first. I need to make sure don't lose any of these recordings. Right, continuing. So I can see the columns. We have fixed acidity, volatile acidity, citric acidity, residual sugar, chlorides, free sulfur dioxide, total sulfur dioxide, density, pH, sulfates, alcohol, quality, everything is here. So we can find out how many rows and columns by calling this. Why is it not running the first time? So we have 1599 rows. Hang on. It's supposed to be 1600, right? However, this is actually not giving you the total number. It's just giving you the highest index. So it starts with 0, it ends in 1599. So the same thing here. It starts with 0 and ends in 12. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Oh, hang on. What's going on? Oh, it's missing the first. No? Not sure. Maybe it's really the number. And I can't really just leave this unresolved. So this is an example with 2 columns. Two, okay, 1 and 2. Okay. Right, I think it's a number, so it's total number. So I think maybe they only have 1599 ones. Kind of odd. Have they made a mistake, or is just something I'm missing? Input shape. How well can we predict a wine's perceived quality from the physiochemical measurements? The target is quality, and the remaining columns are the features. How would you set the input shape parameter for a Keras model on this task? Okay, so quality. So it would be, instead of 12 columns, we would use 11 columns, right? 10. Hang on. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 11. And then the number of rows would be the same. I'm guessing. Let's try and... I'm probably going to get it wrong, but you know. You should have a list of length 1 here. Each entry in the input shape list says how many input values you have in that dimension. And the inputs here are numbers, one-dimensional, and so your answer should look like this. What? I don't understand it. Okay, so I have no idea what this. Why do I have to put this? Now I remember that input shape should be a list. But why underscores, I don't know. Okay, let me review the actual theory, because we talked about input shape here and it didn't register to me. So it has a number here because it's the number of dimensions. So it should be 11, right? I think that was close. Input shape and we put 11. Yes. Okay. That wasn't too difficult. Good to always have exercises so you basically can test what you actually know or what you understood. Define a linear model. Now, define a linear model appropriate for this task. Pay attention to how many inputs and outputs the model should have. Okay, so I need to go and use this as a reference. I'm going to copy it. Input shape 11. And I'm only testing the quality, so it should be okay. Correct. Okay, I got it right. One output and 11 inputs. So number 3, oh, it's the last one. I'm not sure if I'm going to do the optional. Oh, it's the worst. So look at the weights. Internally, Keras represents the weights of a neural network with tensors. Tensors are basically TensorFlow's version of a NumPy array with a few differences that make them better suited to deep learning. One of the most important is that tensors are compatible with GPU and TPU accelerators. TPUs, in fact, are designed specifically for tensor computation. So, if you've learned about NumPy arrays, then you should be able to understand TensorFlow tensors. But yeah, so this is always, it's like a ladder. You learn something and then you use that something to go and learn something else till you get to the top. I know a little bit about NumPy, but I'm no expert. A model's weights are kept in its weights attribute as a list of tensors. Get the weights of the model you defined above. If you want, you could display the weights with something like print weights bias format WB. Okay. So it's giving me some advice. Oops. I'm going to. How do I get the weights? Are they joking? Do I need to go and look for the documentation now? Ah, it's telling me here. It's kept in the weights. What? There's a weights attribute as a list of tensors. So model, I'm going to do another print really. Model dot weights. F. Okay, so for now, you just want to print I'll do that. So I'm doing my search. So I have a tensors here. It's an array of tensors. So these are weights, right? Get the weights. I don't understand this question. Okay. But I can always go into the documentation, find out more about this. Maybe old, but seems like the bias are the sequential model. 3 layers. There's 2 arrays actually. Let's see. Okay. So I think what I need to do here is simple in the sense that I can just since we have there's two elements here. There's let's call it a tensor or a numpy array. I'm going to call it a numpy array. And then we have another df.variable, which is the bias. So this is a tensor. This is the bias. So if I do model.weights, that should be good enough. Then I can print the 2 as it's shown here. Why it's complaining about brackets, I don't know. maybe it's okay. Yeah, it's correct. It's working. Okay. So Keras represents weights as tensors, but also uses tensors to represent data. When you set the input shape argument, you are telling Keras the dimensions of the arrays it should expect for each example in the training data. Setting input shape equal to 3 would create a network accepting vectors of length 3, like 0.2, 0.4, and 0.6. Okay. So I've managed. Do I feel brave enough to do the optional exercise? I might actually stay here for another hour if I'm not lucky. Let me just read it through. And if I think this is too hard for today, I'm just going to call it a day, really. I have to rest. Plot the output of an untrained linear model. The kinds of problems we work on through lesson 5 will be regression problems, where the goal is to predict some numeric target. Regression problems are like curve fitting problems. We are trying to find a curve that best fits the data. Let's take a look at the curve produced by a linear model. You've probably guessed that's the line. I think I know that one as well. We mentioned that before training a model's weights before training, a model's weights are set randomly. Run the cell below a few times to see the different lines produced with a random initialization. There's no coding for this exercise. It's just a demonstration. Thank God. Had enough. Right, so bias 0, weight 164. Let's run it again. 0.2, 0.52. So the bias seems to be set to 0 every time it's here. No, actually it's, let's see if it ever changes. 0.69, 0. It's always 0. Why do I change it? Okay, so you, weight 0. Okay, it keeps changing. Fantastic. Okay, this is enough for lesson 1. I've actually done a lot more than I was intending to do. So just to recap, today I just did the first. Just now I completed the first tutorial in the neural networks course in Kaggle. Also, I did. I set up a Docker container with TensorFlow 2 for Raspberry Pi 4. I've created a Docker image. I've committed everything to GitHub. The next time I'll be like setting up OpenCV with whatever I need, an FFmpeg. In fact, when you set up OpenCV, it comes with FFmpeg. You can actually include it. And then it's a question of making sure you have all the different codecs that you're going to need. I'm going to just include everything I can, so I don't have to always recompile OpenCV, which is not fun. All right, thank you so much for joining us, joining me today, this afternoon on a Saturday, on this adventure, trying to set up a Raspberry Pi and learning neural networks and so on. I really appreciate having done this today, and I hope you did as well. So yeah, that's it for today. Happy coding. Bye bye.